Alright, hello everyone. This one is a video on rate of change. This is very similar to the difference quotient video that I posted a little bit earlier, but it's specifically about rate of change. So we're looking at the rate of change between a point x2 and a point x1, as opposed to a rate of change over the course of unit of distance from x h units onward, which is what a difference quotient is. So we can get started. This is a graph. Class, graph. So I just made an axis that we can make it a little bit of approachable. So we're going to be looking at a function. We're going to look at the function negative x squared plus 8. Alright, so that's an upside down parabola with a y-intercept of 8. And what we want to do is we want to find the rate of change, and we want to find the rate of change from one point to another point. So we're finding from 1 to 2. So from the x-coordinate 1 to the x-coordinate 2. So I'm going to draw an accompanying graph. The lesson is really in the algebra here, but just so that we can relate it to what we saw in class, I'll give you the visual as well. Those are a couple points that I know are on this graph, so I could just grab a parabola through them. So what we want to do is we want to try to find the rate of change from one point to another point. Okay, so we're going to be using 1 and 2 as the 2 points. You can see them in this graph actually. For instance, here is x equals 1, and that means that we're going to be trying to find in order to find the y value of that, we need to figure out what f of 1 is. Now from this graph we can pretty easily see that it does in fact end up being 7, but just so that you know, just so that we can do this in a way that does not involve the picture, let's try to find it algebraically as well. So we're trying to find f of 1, which means we plug 1 in to this function, like so. Plug in 1, so you get negative 1 squared plus 8, so you do 1 squared is 1, so that means you have negative 1 plus 8, in other words 7. So that is going to be your y value. So that value is what corresponds to this point right here. Alright? So that gives us one of our y values, and remember the x value there is 1, because that's the number that we are plugging in. So now we need our second y value. So we can do that by getting f of 2. So we're trying to find the rate of change from 1 to 2. So that's why we picked the 2 points that we did. Okay? So now we're looking at f of 2, and that's this point right here. So the y value of that is, it looks like in this picture that the y value is going to be 4, but we need to figure that out algebraically. So now when we plug in 2 to the function, we will have negative 2 squared plus 8. In other words, we will have negative 4 plus 8, or 4. Alright? So now we have both the x value and the y value for all of those points. So now to recall what the rate of change function is, this is the rate of change function, f of x2 minus f of x1 over x2 minus x1. And we're trying to find, remember, this is basically change in y over change in x. This is just one version of change in y over change in x. Alright? So we're going to try to apply that to this problem. And the way we can do that is by labeling that point as x1 and that point as x2. So now when we fill in these values into the into the equation, we will get a rate of change function. So for instance, we can erase our f of x2 and our x2 and replace it with f of 2 and x2, giving us 4 over 2 here. Similarly, we can replace f of x1 and x1 with the values that we had up here. So that would be x1 right here, and then what it ended up equaling, which was 7. So we can do that just as we did the other one. We'll end up with 7 and 1 there. Just a quick reminder here, these used to be these values, and I'll play it back through here so that we can see what happened. And then you erased. Okay. So now you see what those used to be and what they are now. So which means that we have a fraction, again this is representing the slope, or the rate of change, the average rate of change, and this will equal negative 3 over 1, which means that our rate of change can be expressed as just negative 3. So again, what that represents visually is the slope through those 2 points. So we're saying the average rate of change from this point to this point is going to be negative 3. In other words, for every one unit over we move, 3 units down. So that does represent that picture pretty nicely. Alright, and that's it for rate of change. So if you want to look at the difference quotient video as well that sort of accompanies this one, you can also find that on the website. And if you have any questions, feel free to email me. Alright, thanks guys, bye.